I'm just getting used to it. And I realize there's something I should have brought up before you did this homework. Everyone here should know these identities. We learned these in the trig class, I guess 48C if you took it here. And suddenly these are going to become very useful. This is cosine squared theta minus sine squared theta, but using the Pythagorean theorem, which I'm not even going to mention, everyone knows the Pythagorean identity. If you don't know it by that name, you certainly know it. So that's the Pythagorean trigonometric identity. That allows us to transform this in two useful ways. In particular, this identity is useful because if we have cosine squared or sine squared in an integral, this tells us how we're going to figure that out. So, for example, I said, what is integral of cosine squared theta? We would use this part of the identity. We would say 2 cosine squared theta minus 1 equals cosine 2 theta. And then we'd solve for cosine squared. And we get cosine squared theta equals cosine 2 theta plus 1 over 2. So this becomes cosine 2 theta plus 1 over 2 theta. And now we can go somewhere with it. So I should have mentioned this. Some of you, I noticed, we're going to go over the 6.2 homework because I think it's really important. Some of you decided not to calculate the answer exactly. Instead, you used the calculator, which I understand. You ran into this and didn't know what to do with it. But we'll go over that. Let's see. Anybody just came in. I'm not marking you late. I just want to know who snuck in before. I saw Kim. I saw you. So, anybody else? Let me go through this one more time here. Ed's not here. Kenneth Wong, not here. Liang Su, not here. Omkar, Parth, Yingling. Yingling's not here. So I'm going to suggest something. Everyone who hasn't gotten their homework, please come up and get it. If you take a look, it'll be up here. If you take a look, people did okay on 5.5. If you didn't do very well, you can come talk to me during the break. And some people ace the 6.2 stuff, but a lot of people had problems with some or all of them. Looking back, these were hard problems, and they were hard for the wrong reason. A lot of them were hard because there are a lot of numbers and a lot of negative signs, and it was easy to mix things up. But this being math and having a calculator at your disposal, it's pretty easy to check the results, and you should try and be persistent. You should go for accuracy. And I'm going to try and go over this with you, these 4 problems, because I think it's important. I'm certainly not going to put a lot of problems on the quiz that are going to try and trip you up, just the numbers. And if you did everything else right except the numbers, you get a fair amount of partial credit. But again, I just want to point this out. So, all right. Having said that, I'm going to go over 6.2, so you don't have to ask me about that. Are there any questions about the 5.5 part of this? Take a look. All right, you can think about that too. You can ask me afterwards. Let's start out with. I'm going to try and do most of this from memory. Start out with number 8. It's a very pretty problem. You have 2 functions, curves, y equals 4 cosine squared of x, and y equals secant squared over 4, secant squared of x over 4. And the diagram is really, again, I say, kind of pretty. So 4 cosine squared, it's a cosine, but it goes up to 4. And it's squared, so it's not actually going to do that, but you don't really care about the rest of it anyway. Secant, what does a secant look like? Secant is 1 over the cosine, so secants kind of look like this and like this. But this is squared and divided by 4, so it's kind of like this. And they give you a nice diagram to show you. They don't tell you what these points are, so that's the first thing we'll do. Find out what the limits of integration are. And of course, we do that by setting these functions equal. At this point, it'd be nice to change this to sines and cosines. Turns out to be just 1 over 4 cosine squared x. And we can solve for the cosine, and we're going to get cosine to the 4th is 1/16, or the cosine of x is going to be plus or minus 1/2. Which means that the points are going to be plus or minus pi over 3. So there's negative pi over 3, and here's pi over 3. And that tells us that the integral we want to solve is negative pi over 3 to pi over 3 of the difference. You can see the cosine is going to be the upper function, and squared over x dx. Okay. You could go ahead and simplify this a little. You see it's an even function, so it's just going to be 2 times integral from 0. That's not the way I did it. That's probably a better way to do it. So it's 8 cosine squared x minus secant squared x over 2. So now we're in that position where we need to find the antiderivatives, and that's why I made all this big deal over here about how to do this, right? We're going to have cosine squared, and we're going to replace it by cosine, your 2 theta plus 1 over 2. Right? Otherwise, we don't know what to do with it. So, all right, we have 8, and then cosine 2x plus 1 over 2. All right, that took care of, oh, it's too early to take away the integral sign. And we can just leave this here. This just becomes secant squared x over 2. So let's go ahead and just prepare this in place. This 2 is going to make this a 4. Right. So we've really got 4 times cosine 2x plus 4 minus secant squared over 2. All right, so now we want to find the antiderivatives. The derivative of the sine is the cosine. So the derivative of the sine of 2x is going to be 2 cosine of x. So this just becomes 2 sine of 2x. 4 just becomes 4x. Now the secant squared. Secant squared. What is the antiderivative of the secant squared? You must know this off the top of your head, because you must know what the derivative of the tangent is. What's the derivative of the tangent? Secant squared. Yeah. So obviously the antiderivative is just tangent. And our limits here is 0 pi over 3. Okay. So we're almost done. We have to figure out what the sine of 2 pi over 3 is. Right. You can use whatever method you like. You can use your calculator to figure this out, as long as you know what those funny numbers mean, right? But 2 pi over 3 is this angle here, where this is a 60, 30, 90 triangle. And so the cosine is what? Cosine is the sine of this is what? It's this piece over this, which is square root of 3 over 2. So we have 2 square root of 3 over 2 plus 4 pi over 3 minus, now the tangent of pi over 3, that's over here. again, that's the sine over the cosine, so that's just square root of 3, but it's still over 2. Yeah, this doesn't really turn out that much easier this way, does it? Oh, well, maybe. Sine of 0 is 0. 4x times 0 is 0. So we just have, oh, and the tangent of 0 is 0. So this is just a big 0. Now, did I get the right answer? I did. Oh my gosh. So we just end up with 4 pi over 3 plus square root of 3 over 2. That's really hard to do right the first time. I did not do it right the first time. But I knew I didn't do it right because I checked with my calculator. I had to do it a few times. Many of you got this, and then there was this another answer that, you know, it had a minus sign in there, and you know, obviously it's a similar. Either at least a dozen of you were all working together and came up with the wrong answer, or it's very easy to get that number, and I assume it's the latter. Okay, any who's come in here? Anyone came in? Was Liang here? No? Okay. And Kenneth Wong is still not here. Okay, are there any questions about this? Again, I'm going over this. I think it's worth the time because I also think it's worth your time if you got these wrong. You know, if you want to, you don't have to jot this down. It's online. I put it all online so you can see it. But I think it's worth your while to go over these problems just for the sheer, I don't know, agony of, you know, getting something that's hard to correct. You might have to do it 2 or 3 times. You might have to check the correct, see where you make your mistake. But, you know, math is like that. Sometimes it's just about being very careful with the, you know, with the numbers. All right. Let's see. Number 12. Now these are all kind of the same, you know. Y equals 2x. They're all different, but they're all the same. Plus 3x minus 6. You know, it always helps just to get a little picture, see what you're dealing with. There's a 2x, and then there's a parabola. I don't really know. I don't think really where that parabola is. I'll just make believe it's here. Right, something like this. And I need to know what these points are. So I set these equal. Solve, right? I get x minus 2 times plus 3 equals 0. So x is minus 3 and 2. Right? Minus 3 and 2. So my integral minus 3 to 2. Again, 2x is the upper function. 2x minus x squared minus 3x minus 6 dx, which simplifies to minus x squared minus x minus 6 from minus 3 to 2. Except I'm wrong, because this is minus, so this becomes plus. No, that's not going to do. This was plus. Okay. So, again, here we have this problem of being very careful. Does anyone here think they might want to be a teacher someday? Or even a math teacher? So, you don't have to believe me, but if I sat down and did this with a piece of paper, it's 10 times easier than doing it on the board in front of people. It just, I don't know why. You get better at it after you practice it. So if I get these all right, yay, if I don't. Okay, so what do I have? Minus 8/3, minus 4/2, which is 2 plus 12, minus, okay, so this is, here's where the minuses, if you're not careful, they'll get you. So minus 3 cubed is minus 27, but I have a minus, so plus 27 divided by 3 is 9. Notice there's yet another minus here to deal with. Minus 3 squared is plus 9, but there's a minus, so minus 9/2. And this is minus 18. But now this minus, he goes through, minus, plus, plus, and now I have to add this all up. So what have I got? 18 and 12 is 30, minus 2 is 28. Oh. Let me try that again. Well, 18 and minus 9 is 9, plus 12 is 21, minus 2 is 19. That doesn't feel right. All right. Let's add 8/3 and 9/2, negative 8/3 and positive 9/2. That's negative 16 plus 27 is 11/16. I've already made a mistake, haven't I? I can feel it. It's just arithmetic. How about I do this? That's 9. That's 10. Let me do this carefully. When you're in a rush, see, that's another problem. I'm in a rush. When you're in a rush, it doesn't work out well. 11/16. Okay, so 19, 11/16. Okay. So, oh, 6. Thank you. Okay, so 6 times 19, 6, 104, plus 11 over 6 is 125 over 6, which just happens, I know, is the right answer. Calculus is easy. It's arithmetic. It's the problem. Okay, any questions about this one? Again, if you didn't get it right, go home, forget what you saw on the board, try it. Make sure you get the right answer. Make sure it takes a little practice. All right. Now this one, I didn't really want to do all of these, but I really want to do this one because so many people get the answer 2 for number 16. And I imagine it's just, okay, this is y equals sine of x and y equals sine of 2x. We want to find the area between them within a certain range, I think between 0 and pi. So, is that right? Pretty nice diagram in the book. Yeah, I don't know why I thought there was something funny going on here. So, okay, so sine of x, and then sine of 2x. That's just gonna that. So you have these two pieces here. This is 0 and this is pi. And this is the first one where we're going to have to break it up. And we're going to have to break it up here. And now again, this might have been hard to figure out what this point is. I mean, it's real easy to say sine of x equals sine of 2x, but then you think, what do you do with that? Well, you expand this to 2 sine of x cosine of x, and combining these two, we get 2 sine of x cosine of x minus sine of x equals 0, at which point we can factor sine of x 2 cosine of x minus 1 equals 0, which tells us that either sine of x equals 0, which gives us these 2 points here, 0 and pi, right? Or 2 cosine minus 1 equals 0, which means cosine of x equals a half, which means x equals, in this case, pi over 3. That's what this is, pi over 3. So now, again, we're going to integrate first from 0 to pi over 3, and we'll take sine of 2x minus sine of x. And then we'll have to add this piece, which is from pi over 3 to pi, and, oh, I said x, but I didn't mean that, sine of x. Just the opposite, sine of x minus sine of 2x. Well, let's look at sine of 2x for a second. We want to find its antiderivative. No, that's not. No, we don't have to do anything fancy to that. That's straightforward. You just know that negative cosine of 2x, the derivative of this would be 2 sine of 2x, so we just have to divide this by 2. And here we have minus sine of x, so it's just going to be plus cosine of x. From 0 to pi over 3. And everything's just opposite here, negative cosine of x. Okay, plus cosine of 2x over 2 from pi over 3 to pi. Okay. So now it gets hard. All right. So cosine of 2 times pi over 3, that's the cosine of 2/3 pi. I'll have to draw my little diagram. Okay, so that's 2 pi over 3, and the cosine is this over that, which is a half. I didn't put the minus in yet, I just want to know that that's a half, right? A half, so minus a half. Cosine of pi over 3, that's this guy. That's plus a half. Is that right? Oh, that doesn't feel right. right, well, and let's subtract. Okay, so cosine of 0 is 1, over 2 is a half, minus a half, plus cosine of 0, which is 1. So if I have that right, then it's wrong, because this is negative. Can't be negative. All right. I'm going to cheat and look at... I have to remember their password. Okay. So go to my website if you wish, and go to Homework Solutions, Homework Solution 6, and let's go down and number 16. Oh! Okay, so according to what I did online, this should be a quarter. All right, so cosine of 2 pi over 3, oh, that's negative 1/2. Okay, so this is negative 1/2. This makes it positive, and we divide by 2, and it becomes a quarter. Is that the only mistake I made there? Yeah, I guess so. So I have 3/4 minus a half is 1/4. It is real easy to make mistakes with this. Okay, cosine of pi is negative 1, so a negative of that is 1, plus cosine of 2 pi is negative 1, over 2 is negative a half. Now I have to subtract. Okay, cosine of pi over 3, I think that's a half, so negative a half, plus cosine of 2/3 pi, that's negative a half, divided by 2 is negative a 1/4. So this is 1/2 plus 3/4. 5/4, that's the wrong, it's wrong again. You really have to work hard. 1. Why is this plus a half? Oh, because this was, I'm really confused. According to my homework, cosine of 2 pi, oh, cosine of 2 pi. Cosine of 2 pi is 1, divided by 2 is plus 1/2. Okay. So this becomes 3/2 plus 3/2, no. 3/2 plus 3/4. So this is 6/4. So this is 9/4 plus 1/4 is 10/4 or 5/2, which is the right answer. Oh, is that painful? Well, if you're in excruciating pain, then you know you're doing math, right? Okay.
I wore myself out here. I don't really want to do 24 unless somebody wants me to do it. I will do it. Does anyone want me to do it? Yeah, okay. All right. All right. So 24 says, 24 is the integrate along the y-axis. I am not going to do it by I'm not going to do it by integrating along the x-axis.
That would be teacher torture.
Okay, so we have y equals negative sine of 2y. And x equals cosine of y. So,
And they meet down here somewhere.
and if we look at their diagram, this is
Pi over 2.
I guess I should have written those down, shouldn't I? So x equals cosine of y.
That's this one. And then x equals negative sine of 2y. 2y. That's this one. All right, so once more, we want to know where this y is here. So we equate the two. But again, we're going to expand this. This is negative 2 sine y cosine y. And combining these together, or I guess I could add this to this side, I get cosine y plus 2 sine y cosine y equals 0. I factor 1 plus 2 sine y. And now I know that either cosine y equals 0, which means y equals pi over 2, yeah, that looks good, or sine y equals negative a half.
You can look it up. It's negative pi over 6.
All right, that looks about right. So we're going to integrate along y. I think we decided Tuesday, we're going to have cosine y minus sine 2y, negative pi over 6 to pi. Means we have pluses here. Thank you. So the antiderivative of cosine of y is sine of y. And the antiderivative of sine of 2y is negative cosine of 2y over 2.
And that was the easy part, right?
Okay, so sine of pi over 2, that's got to be 1. I guess I'm going to make this a minus. Minus cosine of 2 times pi over 2, which is cosine of pi, is negative 1. So minus negative 1 over 2, or plus a half. Now we subtract. Okay, so the sine of negative pi over 6. So I'm going to draw my little diagram here to help me. So that's going to be negative a half. And then I subtract cosine of negative pi over 3. That's this angle. Oh, that's positive a half. Is that right? Positive a half over 2. So I have 3 halves minus, oh, this all becomes plus, right? Plus 1/2 plus 1/4. That's 2 1/4 or 9/4. That only took 45 minutes. Okay, any questions about any of this? Any questions about any of the 5.5 stuff? As always, I think someone asked me about some future assignment. I guess not to be handed in the future. If you ever want any of these things online, just send me an email. You can send it now if you have a computer. And over the weekend, I'll put it up for you. How to do it. Yeah. I need a break. Yeah. I guess not. Okay. I'm going to take a break by erasing all the boards. And then we have one more section before the quiz next Tuesday. And this section, we're going to learn a different method of finding a volume, a new method. It can be a little redundant. There are problems where you use the shell method. That's the method we're going to learn. You could also have used the slice method, but sometimes one is easier. Sometimes one is tremendously easier. I'm not going to emphasize this particular method very much because it comes up less often. But here's the idea. We start with a thin rectangle. Has some height, some length, and has a little tiny thickness. We're going to call dx. Incorrectly, we're going to call it dx. We should call it delta x. And we take this and we wrap it around. We wrap it around so that one edge matches up over here. Draw that right. And what we have is, it's like a pipe. It's not a cylinder, because a cylinder would be full, right? It's just the volume between two pipes, between two cylinder surfaces. So, what would the volume of that cylinder be? Well, the radius here is r, we know that L equals 2 pi r. So the volume is going to be 2 pi r times the height times that little dx. So the idea behind the shell method is if you can break up your volume into a bunch of shells, whose height you know based on the radius, some function of radius. What do I want to put? Say, so the height is some function of the radius. Then I can integrate along this radius from, let's say, R1 to R2 of 2 pi back up a little here. Did I miss something? I missed something. Well, we're going to use the variable x here for r, and then this function of r. So let's say I have some volume and kind of from the side it looks like this. It's like a bullet with a hole in it. And I have a height here, which is some function of where I am, in the radius. All right, this is r. Then I'm integrating these shells. I guess another way to look at it would be from the top. I'm taking these little shells and I'm adding up their volumes. It's a very badly drawn circle, but it's okay. So let's try a simple example. Let's take something we know pretty well. Let's take a cone. And we want to find out what this height is as a function of r, right? So we're going to integrate along r. We're going to integrate from 0 to the actual radius of the cone. And there's the height. There's r. So from elementary geometry, we know that the ratio of this piece here, I don't know what to call it yet, to f of x, let me call it r minus x. That sounds like the right thing to call it. The ratio of f of x to r minus x is going to be the same as the ratio of h to r. So I can solve for f of x. So it's going to be h times r minus x over r. Or simplifying h minus hr over x. Except I didn't do that right.
Yeah, no, I did that right. Okay, so let's integrate this. H minus h over r x dx. Well, the antiderivative of h is xh. The antiderivative here is h over r times x squared over 2. And we want to go from 0 to, I guess I should call this big R so we're not confused. Well, no, that's little r. That's right, it's the same r. Okay, so what is this equal to? We have RH minus h r squared over 2 minus 0. So simplifying RH minus RH. What did I do wrong here? Oh. I left the x out of my formula. That was no good. Let's try again. No, you don't need this, so trying again here. X squared over h minus hr x cubed over 3 from 0 to r. Okay. So now we have r squared over h minus h over r cubed over 3. The rest is 0. This is r squared over h. This doesn't look right either. Oh, because I left out my 5h in the formula. Okay, so 5h, okay, minus hr squared over 3. You wore me out. All right, you know what? Let's take a break now. I'll fix this and we'll come back. We'll go on with the shell method.